Hello, in this video we're going to be talking about finding the area between not under one curve but under two different curves. So you can see in this diagram here we're looking for this space in the middle there. In order to find that space in the middle, what we do is we find too much. So you can see if we found the integral under f, we would get all of this stuff down here that we don't want. So what we do is we take away what we would get from the integral of g of x. So in order to find the area between those two curves, you just find the integral of the top minus the bottom, similar to the fundamental theorem of calculus. You can see it happening in action with this problem. This blue line is our top function, so we write that one in first. The red curve is our bottom function, so we do top minus the bottom. Then we check where do those two curves intersect. So the blue and the red meet here at the x value of -2, and then they meet again over here at the positive value of 2. So we're finding the integral from -2 to 2. Now, we could break it down, but it's a lot easier rather than doing a whole ton of integrals. Oftentimes, you're able to, once you set up that top minus bottom, be able to combine the two functions into something that's a little bit easier to integrate. I would rather do these two integrations rather than that one and that one and that one and that one and that one. So let's try it. Let's figure out what our top one minus our bottom one is. So in this problem, our top function is this blue curve. So we want to write that. Oh, no. Ugh. Ugh, that was annoying. Okay, well, we want to do our top curve, which is this blue curve right here. And that's our negative x squared plus 2x plus 3. Then we want to subtract away whatever our bottom curve is, which is this red piece. So that is the x squared minus 4x plus 3. And so then we're going to integrate that thing with respect to x. And we want the start and the end spots of it. So it's starting right there at 0. And then it's ending right there. And I've written all over it, but it's 1, 2, 3 from 0 to 3. Then we could clean up that integral from 0 to 3. And we could say, okay, well, these two, that's a minus 2x squared. And then 2x minus negative 4x, that's plus 6x. And the -3 minus 3 is nothing. So we just have to do that integral right there. Huzzah! The second one's a little bit neater. So here, let me just clear all this, because hopefully you got that down. On our other one, oh, dang it, I've lost that. That. On our other one, now I've got that back, our top function is that x squared. So we want, hey, no, not that color. Our top function is the x squared function. And then our bottom function is the x cubed function. So we want to just integrate that between the two spots that they meet at. So they're meeting right at the origin because 0 squared is the same as 0 cubed. And they're meeting up over here. So that's at 1, because 1 squared is the same as 1 cubed. Now that one we're not able to simplify down. That's as simple as it gets, and so we just integrate that thing to find the area between those two curves. Let's do a couple more examples. Now these ones, they take turns about who is on the top of the thing and who is on the bottom. If we look at this one, there is like a divvy here, like where the two functions are meeting. On this chunk, the red function is on top and then the blue function is on the bottom. On this chunk over here, the blue function is on top and then the red function is on the bottom. That means we do need to separate this out into multiple integrals. So our first integral is going to be in that first area where the two are meeting. I believe that's at, I've written over it again, -1. So I'm going from dang it, pen, not eraser, from -1 to 0, and then we'll have a second integral, and we'll add the two together, going from 0 to 1. On the first integral, in this area right here, our top function is that 3 x cubed minus x, minus our bottom function, which is 0. So minus our 0. And that's all being found the antiderivative with respect to x. On the other one, now our top function is the blue function, which is 0, minus what our bottom function is, in this case, 3x cubed minus x, because now the red curve is below the blue horizontal line. And then we're going to be integrating that with respect to x. And now we could clean this up a little bit to make it look a little more sensible. So this is the integral from -1 to 0 of 3x cubed minus x dx, plus the integral from 0 to 1 of -3 x cubed minus x dx. All done. Now I'm going to erase that and do the other one. So I'll just hit my clear button. There we go. Now in this one, again, they have a spot where they change places right here at 1. So we want to first do the integral that goes from 0 to 1, and then add that to a second integral that's going from 1 to 2, the other spot where they meet up there. On the first integral in this first chunk here, our red function is on top. So that is an x minus 1 cubed. Then we want to subtract our bottom function, which is the x minus 1. That's being found the derivative with respect to x. Then in our second chunk, now the blue function is on top. So we do x minus 1, and then we subtract away our x minus 1 cubed, finding all of that derivative with respect to x. And technically there should be some nice brackets around these. Done. Now, in this one, we're actually going to find the area between these two curves. Well, one of them is a straight line, but whatever. And I've got a couple things off to the side there for helping reasons, which you'll see in a minute. So we want to do the top function minus our bottom function. So our top function is our red function. So we're doing the integral from 1 minus our bottom function, which is the cosine squared x. We're finding our derivative with respect to x. The first place that these two meet is at 0, as you can see right there. And then they meet again over here at pi. Now, we would like to integrate that thing, but we would try to do a u substitution. So we would have u be cosine. But then we would figure out the derivative of cosine, which is negative sign, and we don't have a negative sign to take its place. So we're like, well, dang it. So what we do know, though, and that's why I have this over here, is that 1 minus cosine squared, that is the same as sine squared. Oh, cool. So we're going to replace that integral. Oh, why did I write an equal there? With a sine squared. And you might say, well, big whoop. We still have that same problem of sine squared. That is, we would do a u substitution, and that's u. Sine is u. Derivative of sine is negative cosine, and we're still in trouble. Well, that's where the second one comes in. What we're trying to do is we're trying to make it so we just have that sine function, or just a simple cosine function. So we're going to make this finally using our other integral right here, the integral from 0 to pi of 1 minus cosine of 2x over 2 dx. And this thing, we should be able to do a proper u substitution. Our u is going to be a 2x, and that's not going to cause us any trouble. So let's start doing that. I'm going to break this up into two integrals. So we got the integral from 0 to pi of 1/2 minus the integral from 0 to pi of cosine 2x over 2 dx. dx. Okay. So our u is going to be 2x. Derivative of u is going to be 2. So we just need to stick on, it's going to be a 2 dx. So we're going to need to stick on a 2. So we've got a 1/2 from right here. And then we're going to have a 2 from our u substitution. And then it's going to be the integral of cosine of u du. Over on the other side, we can integrate that, no problem. So I'll just leave it alone. Won't do the integration yet. And then we still got the minus. Okay, so that 1/2 of 2, that's just going to go away. The antiderivative of cosine is going to be sine. Derivative of sine is cosine. So, yeah, that's just going to be a sine. We'll bring our u back in, so that's going to be 2x. Oh, I didn't write from 0 to pi. Going from 0 to pi. The antiderivative of 1/2, that is going to be 1/2 x, going from 0 to pi. I just noticed I was checking my work and I think I made an error. Well, I know I made an error. So our u is 2x, and so then our du is 2 dx. So we want du over 2 to be dx. I just kept it on as a 2. I didn't bring it to the other side. So I want 1 over 2. So we want a quarter of this stuff. So now we just got to substitute this stuff in. So we get 1/2 of a pi minus nothing because it's going to be 1/2 times 0. I still wrote it anyway. I don't know why I did that. Okay, so then a quarter. The sine of 2 pi is 0 minus the sine of 0, which is also 0. So even if I had gotten that wrong, I still would have gotten the right answer. Lucky me. So all of this is just going to simplify down to pi over 2.